Our objective for today, I can factor quadratic trinomials with leading coefficients greater than 1. Let's read together. 1, 2, 3. I can factor quadratic trinomials with leading coefficient greater than 1. So we're continuing the lesson that we started yesterday, except for today we're going to see a couple more things that are concepts that we saw in elementary. I revisited those concepts at the beginning of the school year. I remember at the beginning of the school year, I told you that the first 2 weeks were going to be a piece of cake. You guys remember that? We skipped those 2 weeks like if it was elementary stuff, right? But we're going to revisit now so you guys can see where we're getting a lot of the things that we're doing now with algebra, some basic stuff that we used to do. Okay? Can you get the lights, please, Skylar? Thank you. All right, so here we go. So we don't need a Freyer model because we did that yesterday, yes? We don't need steps because we wrote those down yesterday. So I am going to start here from doing a review from what we did in the past. Now in elementary, you were introduced to square roots, yes? And I remember at the beginning of the school year, we started off by identifying square roots of numbers when we got to real numbers. You guys remember that? Roots. And I said, guys, you guys remember this? Square root of 16, you guys remember that? And then we found out that it was 4. And I said, well, these numbers are known as perfect square numbers. And from there I said, imagine if I showed you a square, because I wanted you to understand where we came with perfect squares. So this is a perfect square. Do you agree with that? And the area, let's say it's 144. So if I was to ask you the measurement of the sides to get this area, you would say what? 12 and 12, because 12 times 12 is 144. One way of writing it is 12 times 12. What's another way of writing it? 12 squared. However, to kind of like transfer it to what we're doing now, I'm going to rewrite these differently. So just pay attention. You don't need to copy this. Just focus. I'm trying to get you guys ready where we're at. So then, let's say I can rewrite this as 10 plus 2. Do you agree with that? Which means this is also 10 plus 2. Do you agree with that? So if I was to rewrite this whole thing again, it would be what? 10 plus 2 and 10 plus 2. Therefore, what is 10 times 10? 10 times 2. 2 times 10. 2 times 2. So if I was to simplify all this, this is 100, dry your peanut. This is 40 plus 4. And what is all this? 144. So we're taking everything that we did in elementary, and now we're kind of like broadening it and applying it to geometry. Now check this out. I know some of you did not do this in elementary because these are more concepts that are intertwined with geometry, and only those teachers in elementary that are comfortable with their mathematics might expand a little bit more. So let's say out of all my classes, maybe like 5 to 10 people might have seen this. However, check this out. When I was sometime back, I used to volunteer during my prep to go do a lesson at elementaries to show them some of these concepts that we do in algebra, but in elementary. So guess what grade I was able to show this for? Third grade. That is correct. Third graders were able to do all this and understand it. Does that make sense? Now check this out. So another way, so we said, check this out. So 12 times 12 is 12 squared. So that means I can rewrite this one as what? 10 plus 2 squared. And that's how we got that. Is that correct? So now check this out. I'm going to show you a shortcut. And actually, it's not a shortcut. It's just patterns in mathematics. Everything with mathematics is about patterns and algorithms. Okay? So everybody go like this. Bear with me. Here we go. Look up. I'm going to show you how to write this without having to do all this. Ready? And you're just paying attention. Here it goes. So far, so good?
Yep.
Next. Now let me voice it out. First term squared. What is 10 squared? 100. Second term squared is 4. That goes at the end. Now, what is 10 times 2? Times 2. And some of you are saying, Mr. Q, why do you say times 2? Well, how many times would it be found in the area model? 2 times. So that's using patterns to write this. Now, the part that really gets to me is that, or for mathematicians, is that when you find a formula or a pattern, does it work for other numbers? Let's find out. Let's see. 10 plus 3 squared. Let's find out. First term squared is 100. Second term squared is, and that goes at the end. Okay. What is 10 times 3? Times 2. That goes here. So let's see the total. 100 plus 60 plus 9, 169. Let's see if it's true. 13 times 13, that's 9, 3, 3, 1, 9, 6, 1. Yes, that is correct. Yeah, isn't 10 plus 3, 13? 13 squared is 13 times 13, yes? Okay. All right. So it worked with that one. Let me continue. 10 plus 5 squared. Here he goes. What goes here? What goes at the end? What goes here? 100. Let's see. 10 times 5 is 50 times 2, that's 100. Let's see. What is 100 plus 100 plus 25? 225. That is true. So it does work. And I can continue going. 11 times 11 is 121, or I can show it as 10 plus 1. 10 plus 1, it should give me that. So this is basic elementary stuff. Now, to get us closer to what we're doing is a challenge. What if I said this? Okay, guys, I'm going to give you a number. Pay attention, please. 100 plus 40 plus 4. And I want you to find me the factors. So watch. Here it goes. Look up. How did I get this number? Look up. I got it from here. You guys see it? So what did I do to get 100? Squared. Is that correct? So what is the opposite of squared? Okay, let's go over the operation. What's the opposite of addition? Opposite of multiplication. What is the opposite of squared? Square root. That is correct. So therefore, square root of 100. 10. The last one. How did we get this 4? By squaring it. What is the opposite? Square root. What is square root of 4? 2. Now check this out. This will only work if this is a perfect square trinomial. How can we check to see if it's a perfect square? By multiplying these two and then times 2, and this should give me this number. What is 10 times 2? Times 2. It is a perfect square trinomial, so I just write the sign of the middle, square. And these are my factors. Let's do another one. Here we go. Let's do 100 plus 100 plus 25. Let's see. Square root of the first. 10. Square root of the last.
5.
5. Let's see if it works. What is 5 times 10 times 2. Does that give me this number? Yes, so I use this sign, and that gives me that, and those are my factors. Are we there so far?
Yes.
Okay, but of course, this is all elementary stuff. Let's crank it up a notch. Example 1. Copy this, please. Yes, please. Copy the instructions only this first time, and then after that you don't have to. It says, example 1A, determine whether each trinomial is a perfect square. If so, factor. If not, explain. Copy it, and then I'm going to go over this one just to make sure we got it. Once again, it says, example 1A, determine whether each trinomial is a perfect square. If so, factor. If not, explain. Trinomial given is 81x squared plus 90x plus 25. Ten seconds. You're only copying right now. Okay, slide your utensils down, look up to the screen. Here we go. So I'm going to zoom in. Look up to the screen. Ready? Here it goes. They want us to see if this is a perfect square trinomial. Well, let's see. Can I take the square root of the first? Yes, that's 9x. Can I take the square root of the last? Yes, that's 5. However, what's the last thing that we need to check to see if this times that times 2 gives me this number? What is 9x times 5?
45.
Times 2? So does it give me that? Yes, so that means this is a perfect square trinomial, which means I can just use this sign at the end and write it to the second power, and these are my factors. Copy that, please. Now, some of you are like, wait, Mr. Q, so I don't have to use the Power Rangers? Well, if you don't understand this, then yes, you will. If you don't know how to do this pattern or this algorithm, then guess what? We do it the old way. What's the old way? 81 times 25 goes on top, 90 goes on the bottom. You have to find all the factors of whatever that is. Is that? Yeah, so this one and that one, and those are my factors, yeah. Let's do another one. Example 1Q. Ready? Let's do 4x squared minus 12x plus 9. Find me the factors using those. Copy and go. And then you zoom out. All right, let's see. Square root of the first, 2x. Square root of the last, 3. What is 2x times 3? Times 2. Does that give me 12x? Yes. What is the sign of the middle? Minus. So this is 2x minus 3 squared. These are my factors. And if you got that, okay, let's do another one. Example 1 super Q. Let's go with 16x squared minus 56x plus 49. Find me my factors, please. See if that's a perfect square trinomial. 10 seconds. Check with the neighbor, see what they got. Okay, let's see. Danny, what'd you get? Hands, if you got 4x minus 7 squared as our factors? That is correct. Let's do another one. Example, mega q. Example, mega q. Let's do 121x to the second minus 66x plus 9. Bless you. Check with the neighbor, see what they got. Brisa M, what'd you get? Factors. Hands, if you got that. That is correct. Show me your fingers, I'll come to R with this. And once again, this is for perfect square trinomials, yes? Okay. Copy this one. Example 1B. You don't have to write the verbatim or the instructions. Just copy the trinomial. Verbatim, which is the words. Oh my goodness. Example 1B. You're like, verbatim? That sounds like fancy. How about if I say finish expeditiously? Which means fast and accurate. Yes! 5, 4, 3, 2, 1. All right, let's go over this one. Square root of the first. Square root of the last. 8. What is 3 times 8? Times 2? 48. Is this 48? No, then this doesn't work. This is not a perfect squared trinomial. And that's all you write. Am I trying to make this clear that even though you can find the square roots of the last or at the ends, not necessarily can you find the factors using this pattern? Is that correct? Yes. Okay. Questions, comments up to right there? We're good? Yeah. All right. So those are perfect square trinomials. Now, we can continue doing more examples, and also we can apply it to word problems, which is very similar to that. Okay? But for tonight, we're only going to be doing the practice first. Tomorrow we'll get into some word problems. So I want to move on to this next example. Example 2A. Example 2A. I'll zoom in. Example 2A. Focus, please. Okay. So one thing I hear some of you saying, Mr. Q, that's not a trinomial. Some of you said it's a binomial. Very true. Good observations. Both of them good observations. Last week we were working on factoring using grouping, right? Using how many terms? 4. This week we started factoring using 3 quadratic trinomials. But then all of a sudden we get to this one. All right. Well, check this out. This has a name. This is known as a, don't write this down yet, this is known as a difference. Difference implying what operation? Subtraction, right? Difference. And this is known as of squares. Why of squares? Because we have 2 terms and they might be perfect squares. Let's see. What is the square root of the first? What is the square root of the other? 2. Since we were able to find the square roots, and it's a difference, this is known as difference of squares. And it's very easy to find the factors. But before I do, let me explain if we were to do that the other way. Ready? Check this out. It's in the other way. Yeah, the way we've been doing it before. So what do you guys notice is missing here in the middle? A variable, is that correct? So I would write it as x squared plus 0x minus 4. Do you agree with that? Okay. Negative 4 goes on top. Yes. What goes on the bottom? 0. Factors of 4 are 1 times 4, 2 times 2. So it seems like what number can I add or subtract to give me 0? 2 and negative 2. I would rewrite this one. Instead of this, I would rewrite this. Is that correct? So watch. X squared plus 2x minus 2x and then negative 4. Are we there so far? All right, so watch. Group. GCF here is x. We're left with x plus 2. GCF here is negative 2, and we're left with x plus 2. So my factors are x plus 2, x minus 2. These are my factors. This is if I do it the other way, right? Now let me show you a pattern on how to do it without doing all that work. Ready? If I was to give you a polynomial like this, what are the 2 things that you see first? That it's a binomial, that it's a subtraction. Well, to check to see if this is a difference of squares, wake up, Amaret. What do we need to do? Find out if we can take the square root of the first. Can we take the square root of the first? Yes. The square root of the last is 2. If this is a difference, then look, I just write this. X minus 2, x plus 2. Factors. Do you need to do all this work? No. I just showed you why it works. Did it work? Did I get the same thing as this? Yes. So therefore, copy that. Because it's a difference of squares. It's a pattern. Example 2b. X squared minus 49. As soon as you're done copying that one, find me the factors of that one. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's see. How can we check to see if this is a difference of squares? Let's see. Square root of the first. X, yes. Can I take the square root of this one? Yes. Is it a subtraction? If it is, then we write x minus 7, x plus 7. These are my factors. Hands, have you got that? Okay. Yes. No. If it is x plus 49. This doesn't work because it's not a difference of squares. Yeah, addition is not a difference. This is sum. This one doesn't work for that. Yes. For right now, I just want this work. Example 2C. Crank it up a notch. 4x squared minus 16. Should be about done. 3, 2, 1. Factors are 2x minus 4, sorry. 2x minus 4 and 2x plus 4. These are my factors. Hands if you got that. Yes? Do another one. Example 2, super cube. Let's do 25x squared y squared z squared minus 81 a squared b squared. Same pattern. Don't get freaked out. 10 seconds. Yeah, you should be getting this if you're not falling asleep, right? Let's go. All right, share with me here, see what they got. Let's see. Angie, go. 5xyz minus 9ab xyz plus 9ab. These are my factors. Hands if you got that. Show me with finger how comfortable you are with perfect squares and different squares. Okay, good. Our home play for tonight. Home play is on page 554, all only. There is no tutoring today. I have a meeting after school. Have a good one, guys. See you guys tomorrow. Bye.